Okay, you guys. So I think that's probably, oh, you're getting there, Ariel? Okay, good. So that's probably a good amount of time. So if we go back over your answers, at what you guys have done, don't want to go there though. Hang on. And if I look at, I'll go back to Ariel because she's still working on it, but Cece, you are doing the right strategy. So when you an average, you are just, or when you're finding the midpoint, you are just taking an average of your x coordinates and you're taking an average of your y coordinates. And what I'm seeing, you guys kind of get hung up in the algorithm, you get hung up in that equation, and then you don't always think about your answer. The very first question in the practice for that lesson had a graph. So I'm going to kind of give you guys an example. So let's just say we had a graph like this. And it's coming up on your screen shortly. All right, and then you guys had a line segment on there somewhere. So we'll just say it looked kind of like that maybe. Like I said, it's still coming up, so it's just a little slower. Okay, so now you guys can kind of see. So we had a line segment like this, and the coordinates, let's see, we're like 6 and 7, -5 and 4. And you guys had to do something like find the midpoint, what you guys are doing now. And you actually saw a visual. And so that's why I was saying with like D or Monique, if you wanted to use this strategy, I mean, you kind of look at this graph and you can see like, oh, the midpoint is somewhere around here maybe, right? But sometimes you guys don't always connect the picture with the math because you get hung up in the math. So then you guys would sit here and you would calculate the math, right? You would take the x coordinate plus the other x coordinate and you would need to divide by 2 and this would come out to be 1/2. But some of you guys would get a different answer maybe because you just didn't add or subtract your numerator correctly. But let's just say I did this. Hang on. And this one would get you like 5.5 or something. So I give you guys odd numbers. But anyway, so if you think about where that is, or did I do that right? 7, 8, 9, 10, 11. Yeah, so. But anyway, so you would come up to where your midpoint is approximately, let's just say instead of getting the correct numbers, you guys would get, I'm just going to make something up. Say you would get like 3 and 10, maybe because you did something wrong, like you did that wrong. That's 310, which is way up here, but that's not even on the line. So always when you guys do a math problem, think to yourself, hey, does that answer make sense? Is that the right number? And then if it's not, you can go, okay, what did I do wrong? Oh, this should be -4. So it's -5, -4. Oh no, it's actually +4. I don't know. Okay. Let's go back. This should be -5, actually it's +4. Anyway, you guys get what I'm saying is that you can go back and you can say, well, where did I make a mistake? Did I add my x's together? Did I add my y's together? Did I divide by 2 correctly? What did I do wrong? And then you can look and see, like if my answer is way up here, that's obviously wrong, right? Because my answer needs to be somewhere on this line segment, somewhere in the middle. So always kind of verify that what you're doing makes sense. So if we go back and we look at some of the problems that you guys did, and I'll look at, like D was pretty close, C4. So if we look at what D has, just because I know he used a different strategy, so you had 9, 0 and -4, 6. So let me just put that on here. 9, 0, -4, 6. Hang on. 9, 0. Give me just a second. Okay, so that's what you had. So if you were to actually plot the line, let's just say, and we would go, okay, here's 9, 0, and then we would go to -4, 6. That's right here, right? So if we were to plot your answer, D, so you did -3, 3. So let's make sure that's right. Yeah, so -3, 3. is right here. So, oh, you did get it? Or you got a different thing? I got it. Oh, in the wrong order? Or in the wrong placement? So, but see, and that's good because then you're looking at it going, huh, well, that doesn't make sense. That can't be the midpoint of this line, right? The midpoint of this line has to be somewhere around here. So you're close maybe with the 3, right, going up, but something's wrong with your x coordinate. So it really helps that when you do these problems, draw it out, make sure your answer makes sense. Okay, so going back to you guys' work, like I said, looks really, really good. And Israel, it looks like you are actually doing the right strategy. So nice job. Do you guys have any questions about midpoints? Okay, so yeah, so it looks like you guys are doing pretty good with that then. And then just make sure that if you haven't already completed the problems where you find the endpoints, they're very similar, but that's where the formula comes into play, as well as being able to look at the line and say, hey, the endpoint I got, is that here or is it somewhere else? So just make sure that you understand the formula, right? It's the average of your x's. So you add your x's together, you divide by 2, and that'll get you the midpoint of your x's. So once you have an equation, it doesn't matter if you have x1, x2, or the midpoint of x, you can plug whatever you need to into the equation to solve for an unknown. And that's where the equation comes into play, which is very helpful compared to only just having the strategy of looking at a line. All right, you guys. Good warm up. So today though, our objective is going to be to find a rule for reflections in the coordinate plane. And then we're going to use our rule to reflect objects in the coordinate plane. So reflections aren't necessarily too hard, but it ties into the lesson of if you have a rule that you can use, then you can use it in any situation. Whereas if your only strategy is just to kind of eyeball and have math sense, while that is a good strategy and that can help you to verify that what you've done is correct, having that rule gives you something like a foundation to solve problems with. All right, so one last thing, important info for success. You guys remember this is the second week, so you should be starting week 2 this week. If you haven't done week 1, get it done as soon as possible, but definitely don't skip. Don't skip week 1 and jump to week 2 because math is really sequential, and if you skip, you lose pieces of that foundation. So make sure that if you haven't completed week 1, that you go in and complete week 1 in order. And then definitely you guys don't put it off because there's only 8 weeks in this quarter, and then all of a sudden you'll be at week 7 going, oh no, I've only completed 2 weeks of math, and it'll be very hard to pass at that point. So stay current, you guys, stay current. All right, let's try this. Okay, you guys. So in your notepads, I'm giving you this point, this red dot, okay? And it's at 4, 5. Those are the coordinates of that dot. So what I want you guys to do in your notepads is determine what would be the new coordinates if this dot was reflected over the x-axis, if it was reflected over the y-axis, and I'm going to add one, the line y equals x. Okay, so all I want for you guys to do is do like an ABC, what would be the new coordinates if you were to reflect that dot first over the x-axis, second over the y-axis, and third over the line y equals x. And I've actually put in that line, y equals x. It's a dotted line right here so you guys can see it to give you some perspective. All right, so Ariel, I don't know if you're there anymore, but we are just going to go on because it looks like a lot of people have the first one. So you guys are seeing that if we're going to go over the x-axis, so CC has 4, -5, and I'm seeing that with most of you guys. Kiona, you have -4, -5. Okay, so let's think about where this would be, you guys. So if we reflect this over the x-axis, so down here, the horizontal is our x-axis, right? So if we're going to reflect that over the x-axis, it would have to be down here somewhere, right? Like right about here. So do you guys agree that's where it would be? Kiana, yes, good. Okay. Monique G, you have it. D, good. Okay, so CC, good. So it looks like you got it figured out. So perfect. So if you look here, you guys, then the new coordinates of this point, if we write them on here, are, hang on, are going to be 4, -5, okay? So by doing that reflection, that's going to help us come up with a rule. All right, now let's look at the y one. So for B, to reflect it over the y-axis, what'd you guys say? So CC, -4, 5. D said the same. Israel, Kiana. Okay, so you guys are all saying -4, 5. So I'm going to go ahead and put this at -4, 5 right here. How does that look? Okay. And then let's look at the final one. So you guys on the last one are saying, let's see what you guys are saying. So I'm seeing -4, -5 from Kiana. I'm seeing 4, 4, -4, -5. I got a lot of -4, -5s. So let's do a -4, -5. So that would be here. Now let me ask you guys this question. This dot up here, if I reflect it over this dashed blue line, is that correct right there? What do you guys think? Okay, so but picture if this is a mirror and you're looking through the mirror, or if something is reflected over, is it going to drop all the way down here though? Oh, yes, Cece, yes. So let's look at Monique G's answer. So she said 4, 4. So hers is here. So that's actually pretty close, Monique. That's pretty close. I think we just need to adjust it a little bit. How about here? All right, what do you guys think about where I put it now? It's really close to what Monique had it. Would that make more sense? Yes, yes. So let's look at the coordinate for that. So that is actually 5, 4 right there. Okay, so let me ask you guys this before I have you guys come up with some rules. Are there any questions about how I got those reflections? So like Monique R, how are you doing with that? You guys don't need to erase them if you don't want to. Yes, Kiana, no, okay, so Kiana, CC, no. D and Israel, Monique R, are you guys good? Oh, good. Excellent, Monique, good. And Monique G, you, looks like you're doing pretty good, and you were really close, and I think that's just sometimes hard to see the numbers. Okay. Was your last answer wrong? D, you said -4, -5. Yeah, because D, if you look where -4, -5 is, that was where we had just had it and we were analyzing it, right? Because -4, -5 is right here. And it'll pop up on your screen just a second. But anyway, it's down here. But if you take this point, the original point here, 4, 5, and you reflect it over the blue line, it wouldn't drop all the way down here, right? It would just reflect over the line. So, can't be down there. Can't be down there. Sorry, D. All right, you guys, so what I'm going to have you guys do is come up with a coordinate rule to use for all reflections. So start with x first. How do you go from 4, 5 down here to 4, negative 5? What do you do to the coordinates? So go ahead and give that a try. Sorry, you guys. Good, so Kiana's off and working on that. Oh, Kiana's moving ahead. Okay, so yeah, you guys, so do them all if you want. Okay, good. So Cece's working on it too. Kiana's working on it. Kiana, I like how you changed. You were kind of thinking about it and then you changed. That was good. All right. Okay, so some of you guys are good. I'm thinking maybe some of you guys aren't sure about the rule, but when you're coming up with rules, you just want to look at patterns. You know, what pattern are you seeing? Like when you reflect over the x-axis, what's different about the coordinates of 4, 5 to 4, negative 5? You know, always think about what is different. All right, so let me actually, because it looks like Cece and Kiana are thinking about it a lot. So I'm actually, Israel, I'm going to ask you, okay? So Israel, are you with me? Type something in the chat. Okay, good. So Israel, what is different about our initial point? I'm going to call this point A right here. What's different about our initial point and our reflected point down here? We'll call this A prime, which means it's reflected. So what's different about the coordinates? Type for me what's different. Good. So the 5 is negative. You're exactly right. Okay, so if I look at Cece's, she said that x is positive, y is negative. So you're stating what's different. Good. And then Kiana, y becomes negative. So you also stated what was different. So that's good. You guys are stating what's different. So when we come up with a rule, though, we have to have some kind of rule. Because what if our first point was down here and our reflected point was up here? That would be a little bit, you couldn't just say, well, make it negative. So does anyone know what we can do to 5, whether it's positive 5 or negative 5, to change the sign? How can you change the sign on something? What can you do to change the sign? Get rid of y? Yes, that would definitely, or add. Good. Okay, so you guys, good guesses. What about multiply or subtract? What about multiply? What could you multiply it by? So Kiana, would you multiply 5 by negative 5 to turn it into negative 5? Multiply. Well, that would make it negative 25, yes. Ah, very good. Negative 1. Yay. You got it. So anytime you multiply something by a -1, what that does is that just causes your sign to become the opposite. So I'm just going to take what you guys said here. We're going to go with the x-axis. What we're going to do is we're going to say we're going to keep x the same, and then we're going to multiply y by a -1. So I'm just going to type -y. So if you do that, no matter where the point is, you will always have a reflection over the x-axis. Yes, Kiona, exactly right. The negative turns the 5 into a negative, and it turns a negative into a positive. So good. All right, so let's look at reflecting over the y-axis. So, who else didn't type one in? Monique G, are you with me? You're so quiet up there. Are you still there? Are you still at Gateway? Yes, very good. Yes, yes, yes. Okay, Monique G, this is just for you. This is just for you. What did you do differently to point A here that had 4, 5 to change it to point A over here to make it be -4, 5? What did I have to do different? We'll call that A prime. So how did this change? What changed between 4, 5 and this point here? What do you think, Monique? Monique? Ah, very good. Very good. And it made the 4 negative. So perfect. So if we are going to do that and I want to write a rule, Dee, why don't you give me a rule that I could write that would basically highlight what Monique is saying? What could I write as my rule to turn 4, 5 into -4, 5, or vice versa? Yeah, exactly, Dee. So what could we do to 4, 5 to turn it into -4, 5? Look up here at the x-axis one. That was our rule. So what could be our rule for the y-axis? What do you think, Dee? Good. Perfect. That's exactly what I was looking for. Nice job. So you would multiply your x coordinate by a -1, and you would leave your y coordinate the same. Good job, you guys. All right, last one. Does anyone want to volunteer? Let me see what Cece said. If the original point are both negative, then the reflect point would be negative. Same if they're positive. True. Let's see what Kiana say. Oh, Kiana. So you said to me, oh, you're volunteering, Kiana? I volunteer as tribute. Oh, I did see that movie actually this weekend. That was, I'm kind of waiting for the third one now. Okay, Kiana, you are exactly right. You're going to reverse X and Y. Oh, Danny's just now coming in. Okay, so if you're going to reflect something over the line Y equals X, notice what happens to the points. So it looks like Kiana had it. I don't know what the +1 is though and the -1, because that could change depending on where your point is, but I like when you said X and Y are reversed. So all we did is we just flip it. So what we would write, then our rule is going to be y comma x. So the point is just reversed is all. All right, you guys, so those formulas you guys will see this week, that will help you, those rules, to reflect things. And the reason that you need a rule right? Because you guys were pretty good about trying to figure out what are the new coordinates if it reflects over x, what's the new coordinates if it reflects over y. And I think now you're starting to understand how to reflect it over y equals x. But what happens if you get stuff like this? And I won't have you guys do this right now, just because we've already been going for 30 minutes. But we'll start with this next time. So if you have 3 points like this, right, and you want to reflect them over the x-axis, over the y-axis, and over the line y equals x, that's not so easy to reflect a triangle like that because it's not on one side or the other. So then if you go to your rules, that will help you to reflect it by just using that rule. So you guys kind of look at this and think about, make sure you write those rules down, and in your notes this week, make sure you write those down. And then next week what we'll do, we'll start off with this as our warm-up, and you guys, depending on what notepad you're in, I'm going to have you come up with the new coordinates for reflecting over x, y, and the line y equals x. So that's what I want you guys to be able to do. Okay, so any questions about knowing what you need to do? Hi, Danny. I know we're almost done. How's it going? You're a little late. It's okay. Apology accepted. You can make up for it though by completing all of your week 1 work and your week 2 work. Yes, yes. Before I see you tomorrow. All right, you guys. So then let's look at your ticket out. You guys can do this. So I'm giving you 3 points, and this is in Schoology. And you want to determine what type of reflection, or maybe a combination of reflections, would give you these new points. So think about the 3 rules. That's all you need. How did point A here in orange turn into point A here in purple? What did you have to do? And you either did one thing or you did a couple of things. So you could have reflected something twice. You could have reflected it over the line y equals x and then reflected it over the y-axis. Or you could have reflected over the x-axis and then the y-axis. So that's what I want you guys to think about. That's what I want you to post in Schoology. And just make sure you justify how you know your answer is correct. So when you guys go in and post, it's really important. A lot of you guys are forgetting that you need to respond to other people's posts too. If you read somebody else's post, I want you to give feedback for them. Like if it's not correct, just say, hey, that can't be, because remember the rule for reflecting over x means that only the y coordinate is negative, and so that doesn't work. So I want you guys to kind of think about that. Yeah, you can watch the webinar, Danny. If you also watch the first lesson for this week, you'll have enough information to do this too. So guys, raise your hand if you understand your ticket out, what you are needing to do in Schoology. Do a hand raise. See Monique G and Cece, Israel, and okay, so very nice, you guys, very good. Awesome job. All right, then that is it for today. So our lesson today recap was just on coming up with rules and the importance of rules when you're doing different types of transformations, and we specifically looked at reflections. But this whole week, week 2, you'll be looking at all different kinds of transformations in geometry. So I will see some of you guys hopefully tomorrow.